Good morning. Okay, so today we have a hard drive problem. This drive right here, it does not spin up at all. Although we know the drive itself probably works. It's almost certainly this board that shorted out somewhere. Now, you could go through this board and try to find shorts and everything else, but today I have another drive very similar. And one would think, well, why don't I just switch this board? That is fine, except for one thing, and that is there's a chip on this board called the BIOS chip or firmware chip that actually, for instance, on this drive, the chip on here tells this board this is the drive size and parameters of the drive. Basically allows this board to talk to this physical drive. So that chip needs to be taken off this board and put on this board, and then we can take this board, put it on this one, and hopefully we'll get it up and running. We're going to be using a docking station to see what happens once we're done. Okay, so put this aside. So the very first thing we want to do is we want to take the bad board off. T6 is the, no, maybe it's not a T6. Might be a bit smaller. Let me get my toolkit out here and see what size it might be. Let me try this here. Yep, that's it. This is iFixit toolkit, and this looks like a T2. No, excuse me, it's a T4. That's the size on this. Now the larger drives, those are typically T6s. Now when we take these boards off, they're almost always all the same size screws, so you don't have to worry about all that. And these boards are pretty sturdy. You don't have to worry about messing up the board too much. And this one's a bad board anyway, so we're not going to worry about it. We're just going to take the board itself off of the drive. Now it's not connected with wires. It has these little kind of spring-loaded connector points that connect here. All right. Okay, so now we've got this board here, and let's get it under the microscope. All right, so looking at this board, there's not a lot to it. There's a couple of big chips, and there's some smaller ones. Now, what we're looking for is a chip with usually 8 pins on it. So that's no good. No good, no good, no good. That one's no good. But way over here, we have one right there. That is almost certainly the BIOS chip that we need. Okay, so what we're going to do, so we don't get confused, is we're going to go ahead and take this chip off right here. And once that chip is off, we will put it aside. Also, it's a good idea to keep the orientation of this chip. Now you'll notice there's a circle. That means pin 1. Okay, pin 1 is where that circle is. And a lot of times these boards will have a mark on the board signifying where chip 1 is. Maybe this is that. Let's see, we got a board or another chip over here. We'll see what it says. Yeah, see, there's another one here saying chip 1. And that's important because you could flip this around and get it backwards, and then obviously it won't work. See if there's another example. Here's another chip right here, and we got chip 1. There's that. And then the last one is interesting because it's got a hole there, or a circle there, no circle there, and a circle here. But these are obviously different kinds. It's a different circle. The ones right there, that smaller one, and there it is right there saying that's pin 1. Okay, so we're going to go back to this right here, this chip here. And the easiest way to get this off of here is we'll put some flux and we will hit it with some hot air and use some tweezers to get it off. But I'm also going to set a weight on the board. I guess I'll do it about like that. I'm setting a weight on the board so when I lift up with the tweezers, I don't move the whole board. Okay, so we've got our tweezers ready to go. And start our hot air. I've got this set at about 400 degrees Celsius at 40% air flow. So what we're going to do is look for the solder to melt. I could have put some low melt solder, but we're removing this so we can get by with just taking it off this way. Board has to heat up first, and it's a very thin board, so it doesn't take too long. Waiting for the solder pads to liquefy. Get a little closer. There we go. All right, it is off. So we're going to take this chip and leave it in the same orientation and just set it aside. Okay? There's that. All right. Okay, we now have the original chip right here. It's very tiny, as you can see. I'm going to set that up aside in the same orientation. And this is the failed board and the drive we want to recover. We'll put that aside. Then we'll take out our T4 and remove this board. Now, something interesting is that both of these boards, they're the same manufacturer, same model and all, but this is a 1 terabyte drive, and the other one that we're fixing, I believe, is a 500. Now, that's not a huge deal because all of the other numbers on this matched up and the board itself looks to be identical. So we should be just fine. All right, so there you go. Board is identical. There's the chip right there. There you go. So we're going to take this chip off of the working board and replace it with the chip here. Okay, so let's go back under the scope. Okay, so this is the chip that we want to remove and then place the one from the bad board here so that this can read the new drive. I also want to show you something that happens in this situation where the chip and the solder have a way of kind of aligning themselves. So because this is high melt solder, I'm going to put some lower melt solder on here, kind of to help this move, to help keep the solder from solidifying quicker. We have a little more time to work with it. A little more solder here. This is also something that makes it easier to remove it. And that's okay that we have a big bridge here of solder. That's totally fine. You know, we mess with it a little bit and it will clear itself. That's not wanting to clear, but that's okay. That's okay. We're removing this anyway. But I kind of, there we go. I wanted to show an example of how this has a way of aligning itself. Okay, so put that away. Now we get our hot air station out, and we will melt this. And it should melt fairly quickly because of the low melt solder we just put on here. There we go. Now we're getting somewhere. Alright. Once you start seeing it really shiny, that's okay. That's when it's good to go. So watch this. When I take my tweezers and push on it, and then I'll heat it up again, it might be blowing it over. Oops. This is super fine motor skills here. Well, that kind of gives you an idea. It sort of wants to stick. It wants to be in that spot where that solder is. All right. So anyway, so now I'm going to clean that up. I could just put that chip right on there. But I kind of want to just clean it up just for the exercise of doing it. So what we want to do is take a little more flux. And we got to remember that's pin 1 right there. Little flux. It can be a mess. That's totally cool. All right. And we'll cut off some. We want to always start with fresh solder wick. See, that's been kind of used. So I cut the end off. It's super cheap, so it's not to worry about wasting it. And then clean off your solder tip. I get harassed about that sometimes. All right, so there's the solder tip, nice and clean. Actually, this is not the solder tip I would normally use. I would normally use a wider chisel looking one, but just for this, it's just a super small job. So we'll just do it with this. Yeah, it doesn't really like this tiny little solder tip. Well, maybe. It's not as dramatic with the smaller tip. Is it working? Kind of, not really. Yeah, see, it's even trying to solder itself to it. Okay, be right back. I'm going to change tips. Okay, I switched to the chisel tip, which is kind of fatter. I'm going to clean that off a little bit. There we go. You can see the difference. It's much bigger and it's flat, so it works a lot better for this sort of work. All right, so put this down here like that. Got to be really careful. I'm going to switch actually a little bit so we don't get rid of that capacitor there. All right. Tell you what, there's the right job, the right tool for the right job makes all the difference. There we go, clean. Now we're going to go down to here and clean these these four. Actually, get some clean solder wick. All right. Here we go. That's it. I need to get a fume extractor. All right. So now we've got that just about ready. One moment. All right. So, you know, normally we could just get the chip on there and call it a day. But the thing is that we kind of want to continue to go with the whole procedure part of this, where we clean things and just kind of show the principle of what we're doing here. So that's pretty clean, huh? It's about as good as it gets, really. All right, so now we have this ready to go. Now we could, I guess if we wanted to, we could just take this chip and use the same solder that's kind of already on there, but we're not going to do that. We're going to go ahead and prep it properly. This is really a data recovery job, so they probably don't want to use the drive again, but in case they needed to access it more than once, it would be a good thing. All right, so I'm going to use my solder, my chisel solder tip, clean it off a little bit. Oh yes, and of course we start with flux. Okay, now put a little solder on our tip, and then hold the board down and just prep these pads. I probably put too much solder on there, but wipe some off. You gotta be real careful. I can already see that I moved that capacitor, but it still seems to look like it's in play. Okay. So now, this is where we do our thing. I'm just going to dab some of that away. Just a little bit. All right, so now, remember we've got our pin 1 right there. Right there. So pin 1's here. That means that when we put this in place, that's where it has to be. All right. Let me clean off my tweezers. I think they're a bit sticky. All right, so now there's a couple ways we could do this. We could use heat, or we could switch back to the narrow pen tip on the soldering iron, and I think that's the way I'm going to go, because I really don't want to end up launching any parts off of this. If it was just any other thing, maybe I would, but this is an important, people's files, right? So, what you're not seeing is me changing this live without burning myself. All right, that worked out. Okay, give it a few seconds for this to heat up. Okay, so now I will take my my tweezers to hold this in place. And we're just going to tack one of these down. There we go. May not be completely hot. There we go. All right, so once those one is in place, see how it's holding on? Then we can do the rest. And this is not completely lined up. Doesn't matter. But just for the sake of OCD, I'm going to line it up a little bit better. Let's see. Right about there, I think will be all right. All right. Yep. And it could have lined up better the other way too. Left and right, I mean. But that's all right. All right. These look good. Now, because I am not left-handed, I'm going to just flip this around completely. There we go. So, just put this on here to hold it down. And we'll just touch these four up and be done. There's one. There's two. There's three. I'm going to do that one again. All right. So now we're just going to push each one of those just so slightly, just to make sure that they're not moving. Let's see here. That one's good. That one's good. 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 And we'll flip it around. There we go. All right, there's that one. Good, 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 good. And that looks like it moved at some point, but it's in place now, so that's fine. So what I'm going to do is just put a little bit of alcohol. I use 99% alcohol. This is actually just to keep it from being so sticky, because it is pretty sticky. All right, and then do this, clean off my microscope. Okay, so now what we have, let me switch back out. Okay, so looking back, I actually reviewed the footage, and it turns out that I did actually move this right here. It was on those two pads right there, and I moved it this way. So it was supposed to be here and here, and it's moved completely over here. So I have to free it from the board right here. It's a little difficult using the hot air station, so I'm just going to try to do it with some tweezers. And boy, that just does not. I think I'm going to attempt this with my hot air tweezers, or excuse me, my hot tweezers, which are basically like two soldering irons working at the same time. Let's see what I can do. Turn it at a little bit of an angle. There we go. There we go. Come on. And then we just move it right there like that. Throw my tweezer on it to hold it in place and then let it solidify. It should be good to go. But if not, we can always touch it up. Yeah, see, I don't even know what that right there is all about, but we're going to clean that off. I think that actually is not attached to anything. Maybe. But it's not bridging anything. It's not causing any kind of short, so I might just leave it. So let's just kind of just touch this up just a little bit. Make sure that we're good. Okay. That looks fine. And that looks fine. All right. Just goes to show you that the smallest little things can happen when you're doing this kind of work. All right, moving forward. Okay, what we have now is a board with the BIOS chip moved over. So we take our drive that we want to work, and we're going to put this right there. And there we go. Fits just like the other one did, so it should be just fine. And using our T4, we're going to put, we don't have to put all the screws in, but I'll just put them all in anyway. Why not? Now, this sort of thing, procedure works on, it's pretty much the same through all drives, whether they're drives like this or larger drives. Mechanical drives is what we're meaning. Doesn't really, it's not the same as far as I know with SSDs. Alright, so once we get these last two screws in, then we will use our docking station and plug it in. Just to recap, the drive came with this, and it did not work. Didn't spin up, didn't do anything. Probably a short in the board. The other drive that I just took this from, took the board from, it did work. So we know that that board was good. So taking this and the other BIOS chip, and I'm throwing them away. We don't want to get confused with what we've got in our hands. All right, let's try this out here. All right, so I actually had to move something around. Okay, now we've got the drive in the docking station. It's turned off. We got this ready to go. Just turned it on. We have a power light and we have a disc light, and it is spinning. So as long as we get this tone when I plug this in, we should be good to go. And it's recognizing the drive. And yep, there we go. We have files. So I'll unplug that. So the good thing about something like that is where you can learn this and have the tools to do this for next to nothing. This is what the companies that do data recovery charge thousands of dollars for. In the last 90 days, I've had jobs from the lab billed out as little as maybe $1,300, all the way up to $4,500 for a job. So Anyway, so there we go. We have a working drive again. All right. So if you have any suggestions, feel free to use my email address. Otherwise, feel free to like and subscribe. And I appreciate you watching this video. If you celebrate, have a nice Christmas, and we'll see you in the next video. Thank you.